Hey everyone, Sefki here, and today we're diving into a cosmic puzzle that's captivated scientists for decades: the search for water on the moon. You might be thinking, water on the moon? Isn't it a barren, dusty wasteland? Well, for a long time that's what we thought too, but recent discoveries have revealed tantalizing hints of lunar water, hidden in ways we never imagined. Join me as we explore the challenges of finding this precious resource in the harshest of environments. Picture this. You're standing on the surface of the moon, bathed in the harsh glare of the sun. The sunlight is unfiltered, relentless, and there's no shade to be found. The temperature around you soars to a scorching 120 degrees Celsius, which is hotter than the hottest deserts on Earth. It's so hot that you could bake cookies right on the lunar surface. Imagine the ground beneath your feet sizzling like a frying pan. Now, imagine trying to find a single drop of water in this unforgiving heat. The search for water becomes a desperate quest, a matter of survival. That's the first challenge we face. The extreme temperatures make it incredibly difficult to sustain any form of life or even to conduct scientific experiments. You see, the moon lacks the protective blanket of an atmosphere like we have here on Earth. This atmosphere not only shields us from harmful radiation, but also helps regulate temperature. So, any water molecules that dare to venture out onto the sunlit surface are quickly vaporized and lost to the vacuum of space. The lack of atmosphere means there's nothing to hold the water in place. It's a process called sublimation, where water transitions directly from a solid state to a gas, bypassing the liquid phase entirely. This makes finding water on the moon a game of cosmic hide-and-seek. Scientists have to be incredibly clever and resourceful, using advanced technology to detect even the smallest traces of water. Rovers equipped with sophisticated instruments scour the lunar surface, analyzing soil samples and searching for signs of water ice hidden in permanently shadowed craters. Every discovery, no matter how small, brings us one step closer to understanding the moon's resources and how we might one day utilize them for sustained human presence. The battle against temperature on the moon is a daunting one, but it's a challenge that drives innovation and fuels our quest for knowledge. The harsh environment forces us to push the boundaries of science and technology, paving the way for future exploration. But don't lose hope just yet. While the moon's surface might be a scorching desert, there are places where the sun's rays never reach. Nestled within deep craters, particularly near the lunar poles, lie regions of perpetual darkness known as cold traps. Here, temperatures plummet to a frigid minus 163 degrees Celsius, colder than the coldest winter night on Earth. These cold traps act like cosmic freezers, preserving water ice for billions of years. Think of them as time capsules, holding clues to the early solar system and potentially the origins of water on Earth. But reaching these hidden reservoirs is no easy feat. The terrain is treacherous, shrouded in perpetual darkness, making exploration a daunting challenge. Now let's talk about the water itself. We're not talking about vast oceans or flowing rivers here. The water we're searching for on the moon exists in minuscule quantities, often measured in parts per million. Imagine trying to find a single grain of sand on an entire beach. That's the scale we're dealing with. These trace amounts of water are scattered throughout the lunar soil, making detection and analysis a monumental task. It's like searching for a cosmic needle in a haystack, requiring highly sensitive instruments and meticulous techniques. But wait, there's more. The moon, our closest celestial neighbor, holds secrets that continue to baffle and amaze scientists. One of the most intriguing mysteries is the presence of water on the moon. While we often think of water as flowing rivers or vast oceans, the moon's water story is far more complex and fascinating. Some of the moon's water isn't just lying around on the surface or hidden in cold traps. These cold traps are areas in permanent shadow, where temperatures are so low that water ice can remain stable for billions of years. But that's not the whole story. It's actually trapped within the lunar rocks themselves. Imagine that. The very rocks that make up the moon's surface are like tiny time capsules holding onto water molecules that have been there for eons. Over billions of years, water molecules have become chemically bound within lunar minerals, forming what we call hydrated minerals. These minerals are like sponges, soaking up water and holding it tightly within their structure. This discovery has profound implications for our understanding of the moon's history and its potential for future exploration. It's like the moon has locked away some of its water in a cosmic vault, requiring specialized tools and techniques to unlock. Scientists are developing innovative methods to extract this water, which could be crucial for sustaining future lunar missions and even establishing a permanent human presence on the moon. And then there are the micrometeorites. These tiny space rocks, often no larger than a grain of sand, constantly bombard the lunar surface. Each impact, though minuscule, plays a significant role in the moon's water story. These tiny space rocks constantly bombard the lunar surface, creating intense heat upon impact. This heat is so intense that it can melt the surrounding lunar soil, a process that has been happening for millions of years. This heat melts the surrounding lunar soil, forming tiny glass beads. And guess what? These glass beads are not just ordinary glass. They have a special role in the moon's water cycle. Some of these glass beads trap water molecules within their glassy structure, adding another layer of complexity to our lunar water hunt. These beads are like tiny treasure chests, each holding a precious drop of water. Understanding these processes helps scientists piece together the moon's intricate water puzzle, revealing a world far more dynamic and mysterious than we ever imagined. Unraveling the molecular mystery. To make matters even more challenging, we need to be sure we're actually detecting water molecules, H2O, and not its close chemical cousin, hydroxyl, OH. You see, both water and hydroxyl have similar spectral signatures, making it difficult for some instruments to distinguish between the two. It's like trying to tell identical twins apart from a distance. But fear not, scientific ingenuity has come to the rescue. NASA's Stratospheric Observatory for Infrared Astronomy, or SOFIA for short, has provided groundbreaking observations. By soaring above Earth's obscuring atmosphere, SOFIA was able to confirm the presence of water molecules in sunlit areas of the moon, a discovery that has significant implications for future lunar exploration. So there you have it. The moon, our closest celestial neighbor, has long fascinated humanity. From ancient myths to modern science, the moon has been a source of wonder and mystery. But one of the most intriguing questions that has puzzled scientists for decades is whether there is water on the moon. Finding water on the moon is no walk in the park. The lunar surface is harsh and unforgiving, with extreme temperatures and a lack of atmosphere. Yet the presence of water could be a game-changer for future space exploration. It's a cosmic detective story, full of twists, turns, and challenges that push the boundaries of our scientific understanding. Scientists have used a variety of methods to search for water, from analyzing lunar samples brought back by the Apollo missions, to using sophisticated instruments on orbiting spacecraft. But despite these hurdles, the quest to uncover the moon's water secrets continues. Recent missions, such as NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1, have provided compelling evidence of water ice in permanently shadowed craters at the lunar poles. Advancements in technology, coupled with ambitious upcoming missions, hold immense promise for unlocking the mysteries of lunar water. New instruments and techniques are being developed to detect and analyze water in ways that were previously unimaginable, and who knows what we might find. The discovery of water on the moon could have profound implications for our understanding of the solar system and the potential for life beyond Earth. The discovery of abundant, accessible water on the moon could revolutionize space exploration, paving the way for future lunar bases, deep space missions, and perhaps even lunar settlements. Water is essential for life, and having a local source could make long-term human presence on the moon feasible. In summary, the moon's environment and the subtle forms in which water exists make detection a formidable task. Water on the moon is not like the lakes and rivers we have on Earth. It is often found in tiny amounts mixed with the lunar soil, or as ice in shadowed craters. However, advancements in technology and upcoming missions hold promise for uncovering the moon's water secrets, crucial for future lunar exploration and potential habitation. As we continue to explore and learn more about our celestial neighbor, we move one step closer to making the dream of living and working on the moon a reality.